Hello everybody, this is Cameron Snow with Danomics.com. So in this video, I want to cover the petrophysical workflow and what that workflow is. And then I also want to cover the difference between what's called a deterministic workflow and a probabilistic workflow. So within petrophysics, we often utilize workflows, and the reason why is because workflows help us ensure consistency in our interpretations, and they also help us to install a certain amount of rigor in our interpretations. So let's get started off. Let's discuss the deterministic workflow. So with the deterministic workflow, what it is we do is we start, we prepare our data, we get it ready to use. We do a interpretation of bad hole, we find where there's washouts, we repair those. Then we move into a clay volume interpretation, we do a TOC analysis. Then we move into a porosity interpretation. Within that porosity interpretation, we'll have options to do things like clay volume corrections, TOC corrections. There's a whole host of methods that can be employed there. Density porosity, a sonic porosity, a neutron density porosity, a number of different ways we can go about that. Then we'll move into a water saturation interpretation. Then we'll apply some cutoffs. Maybe we'll calculate some volumetrics, etc. And that is the standard deterministic workflow. That workflow, it works really well on conventional systems. It's a solid workflow. It is straightforward. It is easy to understand. You should be able to, look at the equations that are involved and understand all of them without too much difficulty. So the second workflow we have here is what we call the probabilistic workflow. And you'll notice the only difference that I have put in between these is there is the mineral inversion step. So we'll go into what mineral inversion is in subsequent videos and try to talk about ways to help you understand that. But for now, just know that mineral inversion is just a technique that uses a little bit of matrices, mathematics to estimate mineral volumes in a rock. And so, when we look at this workflow and we go through and apply it, once again, we start off data prep and conditioning, identify washouts, identify areas where the curve is not behaving correctly, repair those intervals, do a clay volume analysis, do a TOC analysis. So everything sounds very familiar up until this point. And then we're going to do a mineral inversion. And what the mineral inversion does is it allows us to calculate the mineral components of a rock at a step-by-step increment. And then we can use that to calculate a grain density. And then the grain density allows us to calculate a more accurate porosity across an interval. We can also use the mineral inversion to calculate saturation as well, but many interpreters will calculate saturation outside of the inversion. And that's what we're going to discuss in some of the subsequent videos. Then you can go on and apply the cutoffs analysis and the volumetrics. So these are very similar, but there's just a subtle difference in the middle. And just to show you what that subtle difference is in equation format is when we look at a deterministic workflow, so porosity models will use a constant matrix density within a zone. So, here we say porosity is equal to, the row matrix minus our bulk density divided by the matrix density minus the fluid density. In order for you to have a perfect quote perfect answer in this, it must be a constant lithology in your zone. The matrix density needs to be unchanging across the zone in order for your bulk density to reflect your porosity accurately. Now, in the probabilistic workflow, we say that the volume of the minerals is equal to an inverse of our mineral properties matrix times a matrix of our logs. And then we use this to calculate a variable grain density, and that variable grain density can then be plugged back in to our density porosity equation here. And so instead of having one matrix density across an interval, you can have a customized matrix density at every depth step. And so that's really the difference between those two workflows. It's a very subtle difference, but it is a difference that makes quite a change in your interpretations, and I'll go over some examples of that later. But for now, I just want to leave you with these two workflows, and these are what we're going to be talking about in subsequent videos. We're going to go through and we're going to cover each of these in detail, and we're going to be doing that in the Danomics platform. So yeah, I will see you in some later videos, but for now, that is it. I hope this was a little bit useful to you. This is really just set up for what's to come. Thank you, and goodbye.